El Nino is currently brewing in the tropical parts of the Pacific Ocean. Meteorologists expect that El Nino will persist throughout the spring, with a probability of 75 to 85% of it becoming a strong phenomenon. A stronger El Nino definition to come soon implies a greater likelihood of seeing the expected El Nino footprint on weather temperatures and precipitation patterns worldwide. First, the numbers. Our primary indicator of El Nino's growth is the sea surface temperature in the Niño 3.4 region, a square in the central eastern equatorial parts of the Pacific Ocean. Specifically, it's the anomaly, the difference of this temperature from the multi-year average. Multi-year means 1991 to 2020. While here, several decades ago it was discovered that this region has the strongest connection to tropical atmospheric changes. In September, the Niño 3.4 index was at 1.6 Celsius, or 2.9 Fahrenheit, according to ERSS TV5, our most reliable sea surface temperature data set. El Nino is an interconnected system, meaning the ocean and the tropical atmosphere work together to perpetuate and intensify the El Nino phenomenon. The typical pattern of atmospheric circulation over the tropical Pacific, called the Walker circulation, brings raising air, clouds, and storms over the very warm waters of the far western Pacific Ocean, high-level westerly winds, sinking air over the eastern Pacific, and east-to-west surface winds known as the trade winds. The atmospheric half of El Nino clearly displays its stripes. All signs of weakening Walker circulation are present, including increased rainfall and cloudiness over the central eastern Pacific, slow trade winds and upper-level winds, and drier conditions in Indonesia and the far western Pacific. Since we are confident that El Nino will be in play in the winter as well, the next question is how strong will it be? Definitions of strength, which usually also involve the Niño 3.4 index, are unofficial because it doesn't appear that an El Nino with a peak Niño 3.4 index of 1.5 Celsius will have markedly different consequences than one with a peak Niño 3.4 index of 1.4 Celsius. However, as I mentioned earlier, the stronger the El Nino, the more likely it is to affect global temperatures and precipitation patterns as expected. The extraordinary warmth of the world's oceans, also noticeable on the map I showed earlier, means that El Nino is operating in a different world than previous El Nino events. For example, the Atlantic hurricane season during El Nino typically tends to be quieter overall, but this year has seen an active season with 18 named storms, as the very warm North Atlantic Ocean has provided ample fuel. Be sure to subscribe to this channel, like this video to stay updated on the most interesting and popular news early on. Your subscription is essential for more frequent news updates and high quality video viewing.